Hello everyone, welcome to my channel. So I've started offering specialized one-on-one classes in physics, chemistry and math EE for both SL and HL. So for the rates, the standard rate is $35 per hour. If you book like 5 or more classes, it'll be 30, and if you book 10 or more, it'll be 25. So these courses will be tailored to your needs. Whatever you want to learn, we can discuss in these classes. Please don't hesitate to reach out to me. You can contact me at this given email, and yeah, to schedule your class. So with this, let's get started with this paper. Thank you. Hello everyone, welcome back to my channel. So today we'll be solving chemistry SL paper 2 of zone A. So let's get started with the first question. Now, question 1A. You have iron 2 sulfide, which is FeS. It can be produced by heating powdered iron and sulfur together. So first you have to describe the difference between element and compound. So you can write it like this. An element is a pure substance made of only one type of atom and cannot be broken down into simpler substances. Next. What's a compound? Compound is a substance that is made of two or more different elements which are chemically bonded together in a specific proportion. So I can write it like this. Compound is a substance made of two or more different elements chemically bonded together in fixed proportions. Done. Next, we have to okay, so outline why solid FeS is a polar covalent compound. We have to use section 9 and 17. Let's check the data booklet. Section 9 gives you ionization. Okay, section 9 gives you electronegativity, and section 17 gives you the triangle bonding diagram. So from section 9, let's identify the electronegativities of iron and sulfur. And here, so electronegativity value in here, so you have to just rotate the screen once. Iron is here. Iron has electronegativity of 1.8, while sulfur has electronegativity of 2.6. So Fe is 1.8, sulfur is 2.6. Now, to check the triangle, bonding triangle, we need two things, right? Electronegativity difference, which is delta chi, is plotted on the y-axis, and average electronegativity is plotted on the x-axis. I need to find both of them. Okay. So delta chi would be mod of 1.8 minus 2.6. If you mod of negative 0.8, mods eat up the negative, so the delta chi is 0.8, and then average chi, okay, summation delta chi by 2, that is 1.8 plus 2.6 by 2. This 4.4 by 2 gives you 2.2. So my y-axis should be 0.8. 0.8 is somewhere here, will have 0.8. Okay. And then 2.2 would be somewhere here. If you check the bonding triangle, it kind of lies on the polar covalent region. Yeah. And that's why the compound is polar covalent. Point. in the polar covalent region. That's all about part B. Now coming to part C. So student hypothesized that iron sulfide is ionic and therefore can be converted back to iron and sulfur by electrolysis of molten salt. That is correct. The direction of current. This is the positive terminal, this is the negative terminal. S2 minus will be attracted towards the positive terminal. Iron will be attracted towards the negative terminal, right? So here you have to identify which one is the cathode, which one is the anode. The positive one is the anode because at anode there is oxidation. Okay, S2 minus will become S, minus 2 to 0 is oxidation. Cathode is reduction. Fe2 plus will become Fe. 2 plus to 0 is reduction. This is cathode. Write the half equations of reaction occurring at each electrode. So at the negative electrode, Fe is attracted towards the negative electrode. So we get Fe2 plus equals, we'll accept 2 electrons to give you Fe solid. Then S2 minus equals, now actually it'll be 8 S2 minus, which gives you S8 solid plus 16 electrons. Okay. Now in the official mark scheme, either it will be S8 or sulfur solid. Now coming to part 3, we have to contrast one physical property of iron and iron 2 sulfide, right? So iron is a metal, so it will be a good conductor of electricity. While iron 2 sulfide in solid state is an ionic compound, or you can even say it's a polar covalent compound because it will have polar covalent character. So it will not be a good conductor of electricity. Write it like this. Is not a good conductor of electricity. That's it about part 3. Moving on to question 2. Cobalt ions form colored compounds. So first you have to reduce the electronic configuration of cobalt 2 plus. The cobalt atomic number is 27. The electronic configuration will be Ar4s2 3d7. Okay. Now for CO2 plus, we'll remove electrons from the outer shell first. So for first, the two 4s electrons will be removed. And electronic configuration of cobalt 2 plus will be Ar3d7. That's it. Next, we have this equilibrium equation. We have to find the equilibrium constant. So this will be COCl42 minus product divided by reactants CO2 plus Cl minus to the power of 4. That's the answer to B1. Then predict the effect on the value of K and the equilibrium position when solid NaCl is added to the mixture at constant temperature. Right. So when solid NaCl is added, we are increasing the Cl minus concentration. Right. As a result, what happens is the equilibrium will shift to the right in order to decrease the Cl minus concentration, in order to reverse our change. So as Cl minus ion concentration increases, it's in the forward direction. To decrease the Cl minus concentration. But for the value of K, the equilibrium constant remains unchanged. Done. Yeah. So heating an equilibrium mixture that is initially pink changes the color to purplish blue. Did you give an equation where the formation of CuCl4 minus is exothermic or endothermic? Okay. So this is so your left side is pink, right side is blue, correct? I'll just remove these arrows. So the pink color changes to purplish when the mixture is heated. Okay. So when you heat the mixture, the reaction tries to absorb heat. So in the forward direction, heat is absorbed. Yeah. If heat is absorbed in the forward direction, your reaction has to be an endothermic reaction. Delta H has to be positive. So it absorb heat. When temperature is increased, which is only possible if the reaction is endothermic. Next, we have to draw an energy profile for this reaction. It's endothermic, so energy of products will be greater than the energy of reactants. And profile will kind of look like this. This is your delta H, and this will be the EA or the activation energy. Done. Next, we are moving on to question 3. So we have 3.162 grams of calcium carbonate, which reacts with 20 centimeter cube or 4 mole per dm cube HCl. We have to write the equation including state symbols. Yeah. So CaCO3, it's a solid. It reacts with HCl, which is aqueous, to give you CaCl2, which is aqueous, CO2, which is a gas, and H2O, which is a liquid, right? To balance it, I just have to put a 2 in front of HCl. That will make 2 hydrogen and 2 Cl, and rest remains the same. Now we have to deduce which reactant is limiting. So I just have to find the moles first, moles of CaCO3. This will be 3.162, and molar mass of calcium carbonate is 100. So it's 3.162 times 10 to the power minus 2. Next, moles of HCl. This will be concentration times volume. 4 times volume is 20 divided by 1000, converting it to decimeter cube, right? So it's 80 divided by 1000, so 8 times 10 to the power minus 2. Then you have to do moles over stoichiometry coefficient for both of them. So for calcium carbonate, moles is 3.162 times 10 to the power minus 2. The stoichiometry coefficient is 1. Yeah. And then moles by stoichiometry coefficient for HCl. This will be moles of HCl is 8 times 10 to the power minus 2. Stoichiometry coefficient is 2. 4 times 10 to the power minus 2. So the value for CaCO3 is smaller. Yeah. So we can say that CaCO3 is the limiting reactant. Now, you have to calculate the volume in dm cube of the gas produced. So we just need to find the moles of CO2, right? CaCO3 and CHCO2 are 1:1 ratio. So moles of CO2, moles of CaCO3, this would be 1 by 1. So from here, moles of CO2 will be equal to moles of CaCO3. then the moles of CaCO3 is 3.162 times 10 to the power minus 2. Then volume of CO2, this will be moles times the molar volume, right? The molar volume is 22.7. 3.162 times 10 to the power minus 2 times 22.7 gives you 0.718 dm cubed. That is your answer. Now next, the rate of the reaction can be experimentally determined by measuring the volume of gas produced as time progresses. Sketch another curve reaction taking place with acid at higher temperature. If your temperature is higher, right? So let's say this is the equilibrium volume, or this is the maximum volume that will be released, right? So if the reaction is occurring at a higher temperature, then the reaction will be faster. So it will reach this same volume at a much smaller time, like this. Or maybe I can draw it. Yeah. So that's it about question 3. Let's start with question 4. The rate of reaction between iron 3 nitrate and sodium thiosulfate can be measured using time taken for the color change. All right. The reaction is given. It says COCl2 is used as a catalyst. Now, first, we have to explain how catalyst increases the rate of reaction. So, a catalyst would provide an alternative reaction pathway with a lower activation energy, right? And as your activation energy is lower, you will have more successful collisions per unit time, and that will speed up the reaction. With lower activation energy, increases the number of effective collisions. Speeding up the reaction. Done. The next one, the reaction continues until the violet color disappears. The thiosulfate ion S2O3 is oxidized to SO2, Fe3 plus is reduced to Fe2 plus. Reduce the oxidation half equation and the overall redox reaction for the second step. Now S2O3 is converted to SO2. To balance this, first I'll balance the sulfur atoms, right? The oxidation number of sulfur in S2O3 if you do this, 2x plus 3 times minus 2 equals minus 2. So 2x will be plus 4. So x will be plus 2. So here 2 atoms, total oxidation number is plus 4. And in SO2, if you check, x plus 2 times minus 2 is 0, so x is plus 4. So it's plus 8 here. So plus 4 on the left, plus 8 on the right. So I'll add 4 electrons on the right side. Then I have 3 oxygen on the left, 4 oxygen on the right. So I'll add a water to balance the oxygen, and I'll add 2H plus on the right to balance the hydrogen. This is your oxidation half reaction. Now, in order to write the overall redox reaction, I also need the reduction half. This would be the reduction half one. So Fe3 plus is reduced to Fe2 plus. It's just Fe3 plus plus electron gives you Fe2 plus. Done. Now to write the overall reaction, I'll write multiply the second reaction with 4 in order to cancel out electrons. If I multiply it with 4, there'll be 4 electrons here, 4 electrons here. When we add them, this will get cancelled out. Right? So S2O3 plus Fe3 plus H2O gives you twice SO2 will be 4 Fe3 plus twice H plus 4 Fe2 plus. This is your overall redox reaction. Next, we have to deduce the Lewis formula for nitrate ion, NO3 minus ion. Find the total number of valence electrons. Okay. So nitrogen has 5 valence electrons. Each oxygen will have 6 electrons each. And because of the negative charge, we'll have 1 extra valence electron. Valence electron will be 24. So if I want to find the number of valence electron pairs, I'll divide 24 by 2, which will give me 12. Right. So now I'll use these 12 electron pairs to draw the structure. So nitrogen will be surrounded by 3 oxygen, right? First, I have to connect them with single bonds. So out of this 12 electron pairs, I have used 3 pairs to form single bonds, right? Each single bond is 1 electron pair. Now using the 9 electron pairs, I will complete the octet of the outer atoms. Now with this, all 9 electron pairs have been used up and I don't have any electron pair left. Now for each oxygen, the octet is complete. But for nitrogen, there are 6 electron pairs around nitrogen, not 8. So octet of nitrogen is not complete. In this case, what happens is one of the oxygen will leave its lone pair and it will form a double bond with nitrogen. Now in this case, nitrogen actually has 8 electrons, right? And the octet is complete. Now, for this nitrogen, nitrogen needs, generally nitrogen has 1 lone pair. As it has 0 lone pairs here, there will be a plus 1 charge on nitrogen. Oxygen is expected to have 2 lone pairs, but it has 3 lone pairs in these two. So there'll be -1, -1. And for this oxygen, as it has 2 lone pairs, it will have 0 charge. If you add up the charges, you'll see the net charge is -1. Hence, this is the Lewis formula for nitrate ion. We define the molecular geometry of nitrate ion. So we have 3 bond pairs around nitrogen, right? So double bond will be 1 bond pair when it comes to Vesper. So 3 bond pairs around nitrogen, and there are no lone pairs. So 3 bond pairs and no lone pairs will give you a trigonal planar geometry. So planar, done. Now the last question. Wait. No, it's not the last. We have more. Okay. For question 5, an organic compound contains only carbon, hydrogen, and oxygen. Yeah. So you have 3 different elements in this organic compound. 4.32 grams of the compound was combusted completely in oxygen and produced 9.49 grams of CO2 and 5.18 grams of oxygen. We have to find the empirical formula, right? For this, I'll find the moles of CO2 and moles of H2O. Moles of CO2 will be 9.49 divided by 12 plus 2 times 16. Yeah, that will be 0.216. And then moles of H2O would be 5.18 divided by 2 plus 16 gives you 0.288. So moles of carbon will be equal to moles of CO2, 0.216. Moles of hydrogen will be equal to twice the moles of H2O. So 2 times 0.288 gives you 0.576. Now we need to find the mass of oxygen. So mass of oxygen will be total mass of compound minus the mass of carbon, which is 12 times 0.216, minus the mass of hydrogen, which is 1 times 0.576. So you get 1.152 grams from here, and you can find the moles of oxygen. 1.152 divided by 16 gives you 0.072. Now we have to find the simplest whole number ratio. Moles of carbon is to moles of hydrogen is to moles of oxygen. Yeah. So 0.576 is to 1.152 is to 0.072. Next step is you divide all of them with the smallest number. So here the smallest number is 0.072. When you divide them, you'll get it as 3 is to 8 is to 1, which are all like nearly whole numbers. So C3H8O would be your empirical formula. Done. Next, the same organic compound was vaporized completely at a controlled temperature and pressure. 0.108 of grams of the vaporized compound was found to have a volume of 55.7 centimeter cube at 100 degrees and this pressure. We define the moles of the compound, right? So we can directly use the equation PV equals nRT. So N would be PV over RT. Yeah. Pressure is 1 times 10 to the power 5. So volume has to be in meter cubes as the pressure is in Pascal. So remember, if you take pressure as Pascal, volume will be in meter cube. If your pressure is in kilopascal, volume will be in decimeter cube. Right? So as it's in Pascal, I have to convert it to meter cube. So if you divide centimeter cube by 1000, you'll get decimeter cube. If you divide it by 1000 again, you'll get meter cube. R is 8.314. Temperature is 273 plus 100 gives you 373. Fine. Put it in your calculator, you'll get 0.00180. That's the moles of the compound. Into the next part, you have to determine the molar mass of the compound. So mass over molar mass is moles. Okay. So molar mass would be mass over moles. Mass of the sample was 0.108 grams. And then moles we found as 0.00180. When we divide them, we get 60 gram per moles, which is the molar mass of the organic compound. And that's all about question 5. Next, we have question 6, where we are given the chain of a addition polymer. We have to find the structure of monomer. For monomer, we just identify the repeating unit. So you check that this thing has been repeated multiple times. The same thing is exactly here, and so on. Now, what we do is we identify this repeating unit and then just place a double bond in between the carbon atoms. We'll get the monomer. So that is our monomer for part 1. Next part, to describe one chemical property that makes this polymer a useful material. Right? So there's an addition polymer. So addition polymers are chemically unreactive and resistant to corrosion. Right? So it can be used to make containers and packaging. So, chemically unreactive and resistant to corrosion or chemical attack. Suitable for container and packaging. Next, we have an organic compound X, which is an aldehyde. Aldehyde because you have C double bond O on the terminal carbon. The functional group is aldehyde. Reduce the systematic name using IUPAC nomenclature. So here we should number such that your functional group gets the lowest value. So 1, 2, 3, 4, 5, 6. Main chain is of 6 carbon atoms. Out of these 6, you have 3 methyl groups here. So it will be 3, 5, 5 trimethyl. 6 carbon is hex. Between the carbon in the main chain, all are single bonds. So hexane, and you have aldehyde in the first position. So E will be dropped, and you'll just do Al. 355 trimethyl hexanol. That is the name of that. It's the IPAC name. You have to draw an isomer which belongs to a different homologous series. Okay. So for this, we can just draw a ketone. So I'll just shift the position of the double bond. C double bond O CH3, right, which is a ketone. Now molecule X, this one, can undergo both oxidation and reduction. If you oxidize an aldehyde, you will get a carboxylic acid. If you reduce a aldehyde, you'll get a primary alcohol. Okay. So product here would be carboxylic acid. Okay. So Yeah. So if RCHO is X, this will be the reaction. It will become RCOOH. If you use a reducing agent, it will become a primary alcohol, which is RCHO. If you reduce it, use a reducing agent, it will become RCH2OH, which is an alcohol. Yeah. Next, an alkene such as ethene can be used as a starting material for a range of compounds, pairing the product of reaction between ethene and bromine. So if we react ethene with bromine, what happens is the double bond breaks and each carbon gets bonded to one bromine atom. This is your reaction. I mean, this is the product. Outlined by unsaturated molecules such as ethene readily undergoes these type of reaction. So basically in ethene, if you check the double bond, right? Double bond is made up of two bonds. Now, the first bond of double bond is weaker than a single bond. As a result, it can be easily broken, and two new single bonds or two new groups can be added to the molecule. The first pi bond is weak. Hence, the compound is reactive and the double bond, or you can say and the pi bond, okay, can be broken easily and two new groups can be added to the compound. Done. Next is we have to state the general formula for alkene. Alkene is CnH2n. Uh, just make it a bit bigger here. Okay. Now explain in terms of intermolecular forces present, the trends present in the first four alkenes. If you see, the boiling point increases down the group. As the boiling point increases down the group, what happens? We are sure that the intermolecular forces become stronger. Yeah. So logic will be written like this. As the number of carbon atoms increases, the molecular mass and surface area of alkenes will also increase. This leads to stronger London dispersion forces between molecules, which more energy to overcome. So as a result, boiling point increases. Next, and the last question in this paper, ethene reacts with steam to produce ethanol. The reaction is given. You have to find the enthalpy using section 12. So first, let's check what is section 12. Section 12 is bond enthalpies. Okay, so you have to use bond enthalpies to find the enthalpy of this reaction. So If I just draw out all the bonds, it will look like this. Now, enthalpy of the reaction will be summation of bonds broken minus summation of bonds formed. So summation of bonds broken would be, we will break each and every bond on the reactant side and will form each and every bond on the product side. So bonds broken would be, so 1 C double bond C is broken, 4 CH bonds are broken, and 2 OH bonds are broken. Yeah. And bonds formed would be, so 1 CC bond has been formed. So 1, 2, 3, 4, 5. 5 CH bonds are formed. 1 CO bond is formed. 1 OH bond is formed. Yeah. So for bonds broken, so 1 times C double bond C. C double bond C is yeah, 614. And you have CH, 4 times CH. CH is 414. 2 times OH. OH is 463. Now when you add these together, you get 3196 as summation of bonds broken. And then summation of bonds formed. This will be 1 CC bond. CC is 346. 5 CH plus 414, we already know. CO, C single bond O is 358. And then OH is 463. If I add everything up, I'll get 3237. So delta H will be summation of bonds broken 3196 minus summation of bonds formed 3237. When I subtract them, I'll get negative 41. Unit will be kilojoules per mole, which is the answer to the last part of this question. And with this, we finish paper 2 SL of zone A for May 2025 attempt. Yeah. And I'll soon be posting the solutions for paper 2 HL. Thank you so much for watching this video. See you in the next one. Bye.